Net is talking about just the integral. So on the interval of -2 to 2, we're given bounds. You can't find a definite integral without the bounds. So they either have to be given to you directly, or they have to be implied in some kind of word problem. But they have to be there. Otherwise, you can't find a definite integral. Integrate x cubed minus 4x dx. You do that, and you'll get your net area. Well, let's take a look at total area. Graphically, and we talked about this last class. You may or may not have attached any importance to it because most of the time people, and this is not a anecdotal thing, I think it's just a fact of life. People don't fully pay attention to things until they realize it directly applies to them. I'm the same way. If you're one of the few that pays attention to everything everybody says, even when it doesn't even remotely impact you in any way, shape, or form, then, you know, I was going to say good for you, but I don't know if it's good for you. You got to figure something out. That's not the best way to spend your time. You got to prioritize. All right, so my window is -2 to 2 for x min, x max, because that's my A and B. So I'm going to hit graph. And that's going to do enough to get me what I need, right, in terms of the picture. I could graph the entire function, but I don't need the whole function. I just need the relevant piece. What we talked about with total area, and let me just snip this in there. We talked about the idea that we take whatever is given to us visually, find the appropriate areas, but if any of them are negative, we just drop the negative. All right, so what I'm gaining from this is the idea that I'm looking at two seemingly equivalent areas, right? Just one negative, one positive. So just by looking at the picture, I know my net area is going to be 0. All right, or at least I can reasonably assume that it's going to be 0. That's an important thing to keep in mind, knowing and reasonably assuming, because it is entirely possible that this is not symmetric about the origin. It just looks like it is. It's a smidge off, in which case it's like the world's trickiest trick question, but it's not. It is symmetric. That's the idea. All right, and if you find the roots, you see that that's the case. Anyway, if I could just figure out one of these two intervals, this guy or this guy, then I'll have what I need to get my total area. But we also know that the graph of the absolute value of x cubed minus 4x takes the graph of the equivalent function and does an x-axis reflection of all the negative components. So what it's going to do when I graph that in my calculator, it's going to ditch this guy and replace it with this guy. All right? That area there would be the equivalent of this area, just with a positive sign. If you're unsure, just put it in. Little nifty trick, instead of retyping it, especially if you have a really complex equation or expression, you do your alpha window to get your absolute value. But then instead of retyping the function, just pop in alpha trace y1. That'll take the absolute value of your y1 function. And if you want to do a side-by-side comparison, if you have one of the older calculators that are on full or screen, then hit enter on the slashy thing, so that you get one that's regular and one that's bolded. Then hit graph, you see looking good, and then all of a sudden reflection. All right. I went over this concept this morning with my my AP calculus class today, and I was like, quick question. Do you know how to make an absolute value graph from a regular function graph? And they're like, no idea. So I sat down today and I made an activity we're going to go over tomorrow. So, but this is something that's really important. It's just not often taught in pre-calc, calc 1. It doesn't come up. It's like, what's absolute value? Drop negatives. right? But how does that manifest itself visually? Drop the negatives, all right? So make whatever was negative into its positive counterpart. Why would it be any different visually than it would be numerically, all right? So y went from a -2, for example, it becomes a +2. So visually it should bear that out, all right? So my total area should be on the same interval what I would get if I were to integrate the absolute value of the function. All right, there's drawbacks to an approach like this, pretty significant drawbacks, I would say. You walk into a Calc 3 class, and the teacher's like, calculator, what calculator? Why are you using a calculator? You're not allowed to use a calculator. And you're like, well, but I don't know how to take the antiderivative of an absolute value function, and that's how I learned how to find total area. Teacher's going to be like, wow, that sucks, man. Well, you're going to get that one wrong. So there is a little bit of an issue there. If that's the case, if you're in a jam and you can't use the absolute value function, you rely on symmetry. And you say, all right, well, I know that this is a polynomial function. I'll find the area from -2 to 0. Get that answer, that positive answer, and just double it. Because visually I know what it's supposed to look like. It's just a question of making it bear out mathematically. All right? So I put my absolute value into y2. So I'm going to do math 9, -2 to 2. And then I'm going to put in y2, alpha trace y2. Because that's where that function, I have that stored. You retype it if you want. But if you could get in the habit of thinking in terms of y1s and y2s and things like that, then it's going to streamline the amount of work that you have to do in the calculator, the actual physical typing, which takes a while for some of the functions that we're going to be working on. Enter, boom. And again, if you want, you could just go -2 to 0 and get it that way. If you want, this one you might have seen before for Calc 1. I'm going to turn off my y1 equation and just look at y2 in the graph. I find that people, I hate to pick on other teachers, but I'm going to. The teachers that don't know how to use the graphing calculator default to certain approaches and then just tell you, whenever you have a question, can you do something like this on the calculator? They say no. Why do they say no? Because they don't know how to do it, so they're not going to like open the door for that. I know a lot about the calculator. I don't know a lot about everything, but I know a lot about the calculator. One thing that they tend to default to is in the calculate menu, second trace. It's fine. It's an approach that you could use, but it is strictly reliant on your ability to come up with a good viewing window. So if you can't come up with a good viewing window, this method's not going to work well for you. The home screen approach that I was showing you, that's the best way to go because it's irrespective of viewing windows. It would be second trace option 7. It asks you for the lower limit, so -2. It asks you for the upper limit, +2. Shades it in nicely and gives you the 8. All right. Some people are like, that's great, I'll just do that every time. And then you get to the problem on the test that you can't find a window for, and then you come crawling back. All right, so. But the good news is, if you understand that net is the integral itself, just like we talked about last class, and the absolute is the total, but there isn't really much to do.
What's the implication of that's like final bound minus the first bound, right?
Final bound minus the first bound.
FB minus
Oh yeah, that's net area, because that's the fundamental theorem of calculus, which is the definite integral, which is net area.
what notation do you use?
Look,
You saw for that one to get 0. I just didn't know how to write it.
aside from what I wrote here, There's nothing else really to write. Yeah, it's just a individual distinction. We don't say like f prime represents total versus f being net. It's just you get an answer and then just stipulate what that answer is being used for.
Well, I just mean like, how do I, so first thing is say that the area is x to the fourth power divided by 4, minus 4x squared over 2.
Oh, doing it by hand?
Yeah,
Oh.
I'm not sure. You skipped a lot there.
Oh, I skipped nothing. I hit math, option 9, and type some stuff in. That's one thing you got to understand, folks. And this is not just for you, this is for everyone. When I show you stuff on the calculator, it's not really for the purpose of giving you a luxury that you wouldn't otherwise have. It's my way of telling you, do it this way. Forget everything you think you know. Do it this way. I'm going to tell you right now, I'm going to get you with the algebra in the next unit. I'm going to get you pretty good with it. Like use substitution, integration by parts, partial fractions, improper integrals. You're going to analytic your way to get in the next unit. It's going to be a ride. That's all I can say. So when I tell you at this point to just type it in your calculator and get an answer, it's like me giving you Gatorade before a big race. Like all I want to do is get your electrolytes up. Right? That's really all it is. I want to build up your endurance because the next unit is going to be, it's going to be pretty. And by pretty, I mean not that. And that's why in the examples 3, 4, 5 below, it's just write the integral. Because in this unit, I honestly, I mean, we reviewed it a little bit just to kind of get our feet wet. I honestly don't really care very much about your ability to find an integral in this unit. It's in the next unit. It's coming, and it's coming in hot.
So the next, number 2. So can we do the same thing? Just focusing on one side, which we know that it's the same that, right? So can we just focus on one side and then
Double it, cancel, whatever it makes sense to do, yeah. But also, there's nothing stopping you. Math, 9, 0, 3 pi over 2, sine of x, dx. So let me just give you a quick for instance here. So I went to Curry Honda over the weekend to buy a car. And I was talking about monthly payments, interest rates, and stuff like that. Now, there's a lot of exponential functions, logarithms, and things like that that go into finding interest rates, right? So what the guy did when he was giving me the answers that I was looking for, and I could verify it very quickly and easily because I do this kind of stuff. But I also secretly, when he thought I was on my phone, I was on my graphing calculator. So it was kind of like the dorkiest moment in my life, but it was well worth it. So anyway, when he was telling me these numbers, he didn't take out a sheet of loose leaf paper, draw a graph, find an intersection point, find a derivative by hand, an integral and stuff like that. He put it into a computer program. You know, I did my best. All I had was GI4, but like basically we use technology to our advantage. All right, now granted, this is archaic technology. We're going to actually work with some better technology as we move forward through the course. But part of the fluency in math is not just the algebra. Let me just solve it by hand, forget the calculator, forget the computer. 21st century stuff, as you all know. I mean, can you live without technology? I mean, technically, maybe. But would it be a comfortable living? Doubtful. I mean, you know, how about this? If you think it's going to be comfortable living, I'll make a phone call, have your cable shut off. Yeah, I felt somebody have a spike in their blood pressure. Math 9 is the way to go for this unit.
Decimal. So I did something. I did the first one.
Decimal close to that or decimal way off? Decimal way off. So hit mode. Get into radian mode. Yeah, we want to live in radian mode until Calc 3. Radian mode all the way. Calc 3, it's like, forget everything you think you know about trig. You thought radians were important. Forget that. We're going back to degrees. Nobody talks in radians. Because it's a linear measure. So what it does is it puts angles on the same playing field as lines. So anything with a linear distance, so inches, feet, whatever, we can convert back and forth between radians and those. We can think of them the same way because, in fact, a radian is a linear measure, whereas a degree is a measure from center, an angular measure from center. So let me just pop my absolute value in there.
How do you find the button for the absolute value?
Alpha window. It's other places, but those shortcut buttons on the top are really helpful because if you hit alpha and then anything from y equals to trace, you get something you're probably going to find useful. So alpha y equals gives you the fraction stuff. Alpha window gives you the most commonly used functions in the calculator. Derivative, antiderivative. So when I do math 9, it's also alpha window option 4 if you want to go that route. Alpha zoom is linear algebra stuff, so we don't really need that here. Not until Calc 3. Alpha trace is the y stuff. All right. All right, so then the problems below. These are ones that involve a change of function and are also exclusively asking for total area. So we're going from one function to another, depending on the interval. So from 0 to 1, we have the root of x dx. And then from 1 to 2, we have x squared dx. Oops. I almost wrote the 2. All right, we don't have to worry about absolutes or anything like that because only the relevant parts of the graph are above the x-axis, so absolutes are unnecessary. Okay, if the whole graph is above the x-axis and you want to just slap absolutes around just for the hell of it, that, by all means, but definitely not a requirement. Number 6. In this case, you have an area that's not adjacent to a particular axis. All right, so what I would want to do is, well, you can make a reasonable assumption, but I'm going to pretend that I don't know, or at least I'm not convinced that these two areas are exactly the same. As it turns out, they are. If you were to guess that they are on a test, you'd be right, and no one would be the wiser. But let's assume that we don't really know that. All right. So if I wanted to find the area of the shaded region, what I would need to do is find the area below this line, right, which has a value of y equals 2. And that's going all the way from 0 to pi. And then I would subtract from that the area of all the stuff that I don't want. So that would be this stuff. 0 to pi again, and the function 1 plus cosine x. dx. And that's only to fulfill the requirement of writing an integral or sum of integrals that can be used to find the total area. The reality is, if I were just finding the area, and I was not convinced that those two regions were equivalent, I would do the integral from 0 to pi, and then I would subtract it from 2 pi, because that's the area of the rectangle, base times height. Right? So you can go that route if you don't have the requirement of using any particular approach.
I would have thought that the area for one thing would be 2 pi, no? Or is it?
The whole shebang is 2 pi, yeah. And that's what you would get if you integrate 2. Because difference between the bounds multiplied by the integrand. So you get 2 pi that way.
Would I have done it wrong if I wrote 2 pi?
In this case, based on the directions, yeah, because it said write an integral or a sum of integrals. So you'd have to have your entire expression made up of integrals. I feel bad taking off the credit, though.